How's it going, ladies and gentlemen? Mr. Johnny here once again. This time we're going to take a look at 4.3 problems, acid-base reaction stuff. All right, so 11. Of the following, which is the weakest acid? Well, the first thing that you need to remember is remember all of your strong acids. And then you go, all right, well, if they're all strong acids except for one, then I know. All right, so HCl, strong acid, not going to be the weakest. HI, strong acid. HNO3, strong acid. HClO4, strong acid. HF is a weak acid. Right? So these are things that you're going to have to commit to memory. So HF is a weak acid, right? So I got my list of strong acids here. It's not on it, so the rest of them are. HF is my weakest acid. All right, which of the following is a diprotic acid? So you got to remember diprotic means two protons, which is just an H plus ion. So you go, all right, well, hydrochloric acid I know is HCl. Hydrofluoric acid is HF. Sulfuric acid, well, sulfuric, if it ends in ic, it was 8, so it was a sulfate ion, which is the SO4 minus 2, which means that I have 2 H pluses. Looking good for my answer. Nitric acid means the ic ending tells me that it was nitrate, which is that NO3 minus, which means I have just one hydrogen. It's monoprotic, so it's not going to be D. And phosphoric acid means that I had the phosphate, right? The ic. If I'm going backwards to what it was the 8 ending, so phosphate. It's at PO4, which has a minus 3, which means that it has 3 H pluses, which would be triprotic, so it's not going to be E. So correct answer is going to be C. All right, 13. Which of the following solutions will have the greatest concentration of hydroxide ions? So you're going to have to figure out the concentration of the hydroxide ion. So if it's magnesium hydroxide, well, I know the formula for that is MgOH and then 2 OHs. And then rubidium hydroxide is going to be Rb, which has plus 1 because it's in the group 1, OH. And then hydrochloric acid, we don't even got to worry about that because it's an acid. It's not giving off hydroxide ion. And then ammonia is a weak acid, so let's keep that in mind. The other ones it's a weak base. The rest of them are strong bases, so it's probably not going to be D. And then beryllium hydroxide. I know that Be is a plus 2, which means it's going to be BeOH in parentheses 2. So now let's do the math. Well, if I want to know the concentration of hydroxide ion, I got to take the concentration of the base and then times it by how many hydroxide ions there are in one formula of that base. So for magnesium hydroxide, it'd be 0.200 molar times 2 because you have 2 OHs, and that gives me a total concentration of 0.400 for the OH minus. And then I'm going to do the same for the rest. Well, Rb has just one hydroxide ion, so it's going to be just what the concentration was. So that's going to be 0.150 for hydroxide. Ammonia, it's a weak base, so it's not even going to be 0.1. So I know I can rule that out for sure now. And then beryllium hydroxide, well, let's see. I get 2 of them, so it's really going to be 0.120 times 2, which is going to give me 0.240 molar. So the one with the greatest hydroxide ion concentration is going to be A. 14. What products are formed from a neutralization reaction between a metal hydroxide and an acid? So it's saying it doesn't matter what the metal is, it's a metal hydroxide. And then an acid, which is going to be like, you get an H plus and then some anion. Well, you always end up with water, because that OH minus and the H plus are going to meet up, and then a salt. You're going to get whatever the metal is and the anion. So the generic formula is acid plus base is going to give you water and a salt. So the correct answer would be water and a salt. 15, last question. What is or are the spectator ions in the reaction between aqueous hydrochloric acid and aqueous ammonia? Well, let's take a look at it. If it's aqueous hydrochloric acid, it's going to break up into H plus and the chloride ion. And aqueous ammonia, well, ammonia is just that NH3, and it's going to be aqueous. And then it's going to give me, what could happen here? Well, the chloride ion and the hydrogen ion are dissociated. And the hydrogen ion, if you want to get into it, is going to be attracted to the lone pair of electrons on that ammonia, and it's going to bond to it. So we're going to end up with NH4, which has a positive charge because of the additional H plus that's going onto it, and a chloride ion. Now this is going to be soluble, so they're just going to end up like looking like this. NH4 plus aqueous and chloride ion aqueous. And that is what you're going to get. And it says, what are the spectator ions? Well, if we take a look, the chloride ion started off as an ion all by itself, ended up as an ion all by itself. So that is the spectator ion, Cl minus, which is aqueous. All right, so I hope you found that helpful. Bring questions. I'll see you in class.